Welcome to this video segment on cursors. This is Claire Rajan, and in this tutorial I'll be explaining explicit cursors. I introduced the concept of cursors in my earlier tutorial with implicit cursors. Recalling, a cursor is defined as a work area where a SQL statement is executed. In PL SQL programming, there are two types of cursors, namely implicit cursors and explicit cursors. In this tutorial, I'll be discussing explicit cursors. The explicit cursor is a user-defined cursor that is associated with select statements in a PL SQL block. If you write a select statement that will return more than a single row, then you will have to use an explicit cursor in the program. The explicit cursor allows you to manipulate each row returned by the select statement. However, if you use a cursor, you must keep in mind that you will have to perform certain manual steps that are associated with explicit cursor manipulation. To understand the behavior and the use of the explicit cursor, I'll be using the help of a PL SQL program. Now, before we do that, let's have a look at some data in the employees table. Now, there are four columns: EMPNO, which is the employee number, ENAME, the employee's name, salary, which is the salary of the employee, and DPTNO, the department number the employee belongs to. There are three rows in the table. Notice that there are two employees who belong to department number 20. Now consider the PL SQL block that has been written to display the names of the employees in department 20. The program reads as declare VENAME varchar 2 of 45, begin, select ENAME into VENAME from employees where DEPTNO equal to 20, DBMS underscore output dot put underscore line VENAME end. Now in this program, the select statement should retrieve two rows based on the condition department number equal to 20. But when this program is executed, it returns the error exact fetch returns more than requested number of rows. Now this is because the query returns more than one row, and you will have to rewrite this program using an explicit cursor. I mentioned in the previous slide that if you are using an explicit cursor, there are some manual steps that need to be performed. There are basically four steps. Two of them are mentioned on this slide and two on the next. To begin with, you must declare the cursor. This is done in the declaration section. When you declare the cursor, you give the cursor a name and you associate it with a select statement. This select statement is the statement that returns multiple rows. The syntax of cursor declaration is cursor name is followed by the select statement. The example declaration has been provided as cursor C1 is select ENAME from employees where department number equal to 20. The next step is to open the cursor. This is also done within the body of the PL SQL block. Opening the cursor results in the execution of the select statement to create a set of rows which are referred to as an active set. The syntax is open cursor name, and the example for opening the cursor called C1 is open C1. The third step in cursor manipulation is fetching the cursor. Now this is how you bring the values from a row of the cursor into memory variables for processing. This step is also performed in the body of the program. By fetching the values into memory variables, you can individually work with the values generated by a single row of the select statement. The syntax of this step is fetch cursor name into variable, comma, and any number of variables based on the number of columns that the cursor is associated with. Now, in the example, the statement is fetch C1 into VENAME. Here VENAME is the name of a memory variable. The last step in cursor manipulation is closing the cursor. When this step is executed, the cursor is released and all the memory occupied by the rows returned by the query are released. This step is executed in the body of the program, and the syntax is close cursor name. To close the cursor called C1, you would issue the statement close C1. Here we'll take a closer look at the step of fetching the cursor. Fetching of a cursor is done so that the values that are held by a row of the cursor are available to the program for manipulation. By fetching the row, you populate the current row's values into memory variables. Now, because the cursor is made up of many rows, you will have to repeat the process of fetching multiple times for the number of rows you wish to manipulate. Therefore, a fetch statement is typically enclosed within a loop type of construct that could be a loop end loop statement or a while loop statement. The for loop can also be used for cursor manipulation. Now, in the example, the keyword loop is followed by the fetch. Remember that a loop construct is endless unless you have a way of breaking from the loop. Following the fetch, you must write a statement that will cause the looping to stop, and this is typically done when all the rows have been fetched. I'll explain this point a little more when I teach you about the attributes of the explicit cursor. Now, here is a program that was initially discussed in this tutorial. I have made some changes to it to incorporate the explicit cursor. The program now reads as declare v-ename varchar2 of 45. Cursor C1 is select ename from employees where deptno equal to 20. Begin, open C1, loop, fetch C1 into v-ename, followed by a statement to exit the loop, dbms output line v-ename, end loop, end. Now, the variable v-ename is declared so that the value fetched by the cursor can be populated into it. The cursor is called C1 and it's associated with that select statement that retrieves the names of the employees in department 20. In the body of the program, the cursor is opened so that the select statement is executed and an active set of rows generated. Following this, we have a loop that encloses the fetch, which allows you to retrieve the first row and subsequent rows from the cursor into the memory variable called v-ename, one row at a time. Following the fetch would be a statement that would break from the loop when no more rows are available in the cursor and the fetch fails. Now, if a row is found, then the value from the memory variable v-ename is being displayed with the dbms output line statement on the screen. So, as each employee's name is fetched from the cursor, it will be displayed on the screen. The loop ends followed by the end of the program. We'll now go over the attributes of the explicit cursor. These attributes play an important role in identifying the status of an explicit cursor. There are four important attributes: %is open, %found, %not found, and %row count. The syntax is cursor name followed by the attribute, so that the attribute %found for a cursor called C1 would be C1% found. The first attribute is %is open. It's a Boolean attribute returning a true or false value. True is returned after the cursor is opened and false when the cursor is not opened. The %found attribute is Boolean and returns true or false. True is returned when the fetch statement finds a row in the cursor, and false when a fetch statement does not return a row from the cursor. The %not found attribute is Boolean and returns true or false. True is returned when a fetch statement does not find a row in the cursor, and false when a fetch statement returns a row from the cursor. The %row count attribute is numeric. It returns a numeric value associated with the row being fetched. The first row fetched is row count 1 and the second row is row count 2, and so on. Now, this example program shows you the use of the isOpen attribute. The first part is the same, where the variable v-ename is declared and the cursor C1 is also declared. However, the open statement is now part of an if condition. The if condition checks to see if the cursor is already open or not. It will open C1 only when the not is open is true. and the rest of the program is the same as I've discussed before. In this program, you're going to see the use of the %NotFound attribute. This is the attribute that is very useful to break from the loop that the fetch is written in. Notice the statement immediately following the fetch is exit when C1% not found. When there are no more rows in the cursor, the fetch will fail and the %NotFound attribute will become true. And that is when you might want to break or exit from the loop. The %found is the opposite of %NotFound. So as long as a row from the cursor is fetched, you would want to process the values generated by the fetch. Otherwise, you want to exit the loop. Now in the example, immediately after the first fetch is done, a check is being done using an if C1% found condition. You want to display the name, else you want to exit from the loop. Now here is a program that shows you the usage of the %RowCount attribute. If you want to display the names of the employees along with a number indicating 1 for the first name, 2 for the second person's name, then you can use the %RowCount attribute. Look at the desired output at the bottom of the slide. The name Jack is prefixed by the words row number and followed by the number 1. The name Rick is prefixed by row number 2. Now this can be easily accomplished with the %RowCount attribute. In the DBMS output line statement that is displaying the name, a reference to C1% row count is being made, and the statement now reads as dbms_output.put_line open parentheses and within single quotes row number : close single quote double pipe C1% row count double pipe the colon inside single quotes double piped with the name of the variable VE name. Now this program also shows you the usage of the other attributes such as isOpen and %NotFound, and it makes it a complete program with all the necessary validations that you might want to use when writing a program that uses explicit cursors. Now here is a program for you to try that uses an explicit cursor. You must write a PL SQL block that will retrieve the names and the salaries of the employees who earn a salary greater than 4,500. The program should display the name of the employee and their salary. Use a cursor called empcur and the %NotFound attribute to ensure that processing stops after all the rows from the cursor have been fetched. Now you can pause this video for just a few moments if you wish to try it, as the solution is on the next slide. The solution to for the program to try is displayed on this slide. I hope you have found this tutorial useful. For more videos, tutorials and articles related to Oracle topics, you can look at the oraclecoach.com website. Thank you for your time and thank you for listening.